Today, we'll learn about Newton's three laws of motion, the foundation of classical mechanics. Sir Isaac Newton formulated these laws in the late 17th century, and they've been essential to our understanding of how objects move ever since. Let's start with Newton's first law, also known as the law of inertia. The first law states that an object at rest stays at rest, and an object in motion stays in motion at a constant speed and in a straight line, unless acted on by an outside net force. This means that objects naturally resist changes to their motion. We call this resistance inertia. Let's look at some examples of Newton's first law. First, consider a soccer ball resting on the grass. The ball will stay at rest unless a force acts on it. When you kick the ball, you apply a force that changes its state of motion. For our second example, imagine a skateboarder coasting along a flat surface. Once in motion, the skateboarder will continue moving at constant speed in a straight line until friction or some other force slows them down. This is Newton's first law in action again. Now let's move on to Newton's second law, also known as the law of acceleration. The second law states that the acceleration of an object depends on the net force acting on it and its mass. Mathematically, we can write this as F net equals m times a, where F net is the net force, m is the mass, and a is the acceleration. What this means is that if you push harder on an object, it will accelerate more, and if an object is heavier, it will accelerate less for the same force. Let's see Newton's second law in action with a shopping cart example. Here we have two shopping carts, an empty one with a mass of 15 kilograms and a full one with a mass of 45 kilograms. If we apply the same force of 30 newtons to both carts, we can calculate their accelerations using the formula A equals F over m. For the empty cart, the acceleration is 30 newtons divided by 15 kilograms, which equals 2 meters per second squared. For the full cart, the acceleration is 30 newtons divided by 45 kilograms, which equals 0.67 meters per second squared. As you can see, the empty cart accelerates 3 times faster than the full cart when the same force is applied, exactly as Newton's second law predicts. Finally, let's discuss Newton's third law, also known as the law of action and reaction. The third law states that for every action force, there is an equal and opposite reaction force. Mathematically, we write this as Fa on B equals negative Fb on A. This means that whenever one object pushes on a second object, the second object pushes back with equal force in the opposite direction. Let's look at some examples of Newton's third law. First, imagine someone jumping from a small boat. When the person pushes against the boat to jump forward, the boat is pushed backward with equal force. The person exerts a force on the boat, and the boat exerts an equal and opposite force on the person. This is why the boat moves backward when someone jumps from it. For our second example, let's look at how rockets work. A rocket's engines push exhaust gases downward with a great force. According to Newton's third law, the gases push back on the rocket with an equal force in the upward direction. This reaction force is what propels the rocket upward. Let's summarize Newton's three laws of motion. The first law, or law of inertia, states that objects resist changes in their motion unless acted upon by a force. The second law, or law of acceleration, tells us that force equals mass times acceleration, describing how objects respond to forces. And the third law, or law of action and reaction, states that forces always come in equal and opposite pairs. These three laws form the foundation of classical mechanics and help us understand how objects move in our everyday world.